Today we're doing 3.3, a system of linear inequalities. Our vocabulary is a system of linear inequalities. And it is a set of two or more linear inequalities with the same variables. So inequalities mean greater than or equal to, less than or equal to. Those are your inequalities. So instead of lines, we have lines that are shaded. And your solution for these types of problems is an infinite set of points represented by a shaded graph. You're going to have a graph with, lines shaded, a dotted line shaded, and where they overlap is your actual solution. Let's go through an example. Example 1. So we need to graph both these lines and shade them, and our solution is where the shading overlaps. So first, our first equation is negative 2x plus 4. So we go to plus 4 and put a dot, 1, 2, 3, 4. And then we use our slope of negative 2, positive 1, and put a dot. And we're going to do a solid line. And again, you guys have to use straight edges. It's very difficult for me to use a straight edge on my iPad. So that's about as good as it gets. And we're shading below it. And I'm going to actually do lines like this, and you'll see why. Okay, I could use two colors, but you're going to be working with a pencil, so we're just going to keep everything one color, and you'll see the solution. Next is y is greater than x minus 3. So we go to we go to our y-intercept of negative 3, 1, 2, 3, and put a dot. And our slope of positive 1, positive 1. Our line is dashed. And we shade above the line. And again, I'm just drawing lines like this. And your solution is where the two linear inequalities overlap. And you see I've signified that by the shading going up. And let's try this, see if it works. And the shading going down. So where they overlap is really, see I'm lightly drawing with yellow, is in this area. So you have to be really neat with your graphs this time. It's really, really important. So that is actually the solution. Let's try another one. Okay, I've made some notes. Everything has to be in slope-intercept form. You need to make sure you draw your solid and dashed boundary lines, and you have to shade in the right direction. Like I said in the first slide, the solution for the system is the shaded area. Every ordered pair in the shaded area is the solution. If you're unsure of what direction to shade, use your origin as a test point. Okay, one more. Here I'm going to remind you guys that when you have x, excuse me, let's erase that, get my pen working right again. When you have x equals a number, your line is vertical. When you have y equals a number, your line is horizontal. So x is less than 3. Let's go to x equals 3, 1, 2, 3, and draw a line. Oh, let's erase that, I think. Oh, come on. Let's go to x equals 3, 1, 2, 3, and do a dashed line going up. And let's shade our x is less than 3. So we want to include everything smaller than x equals 3. And then we need to put this second one into slope-intercept form. Subtract 3x from both sides. Negative 2y less than or equal to negative 3x plus 2. Divide everything by negative 2. And when I divide by negative, I flip my inequality. So there's my equation I need to graph. So my y-intercept is -1. It's hard to read your graph at this point. There is -1, and my slope is +1, 2, 3, +1, 2. Solid line and it is greater than. And just like last time, your solution is where it overlaps. So it overlaps everything in this area. And you do not have to color it in at the end. I'm just trying to be really careful while you guys are learning. Okay, you try it. That means you need to push pause and actually try it. Yes, your y-intercept is 1.5, but you guys can do it. There's your answer. Try the next one. Another you try, notice you have y is less than or equal to 4. Remember if that's vertical or horizontal. In the second equation you have to put in slope-intercept form. And there's your answer. Y is less than or equal to 4 is a horizontal solid line, shading everything underneath. Alright, application problems. Now we have systems of inequalities. We still have 2 equations and we're graphing and shading, and our solution is everywhere in the shaded area. Lauren wants to paint no more than 70 plates for the art show. It costs her at least $50 plus $2 per item to produce red plates and $3 per item to produce gold plates. She wants to spend no more than $215. Write and graph a system of inequalities that can be used to determine the number of each plate Lauren can make. So let's just pick. X is going to be the number of red plates that Lauren can paint, and Y is going to be the number of gold plates. Let's come up with 2 equations. First one is going to be our easy one. X plus Y. She can paint no more than 70. So that's going to be less than or equal to 70. The amount of money she's willing to spend is $2 for a red plate and $3 for a gold plate. And she wants to spend no more than $250. So what she wants to spend has to be less than or equal to $215. Okay? She also is going to have her X, the number of red plates, is going to be greater than or equal to 0, and the Y, the number of gold plates, is going to be greater than or equal to 0. Okay, write those down and remember them for the next slide. We actually forgot one thing on this page. Let's find it. It cost her at least $50. We forgot that. So this inequality that talks about money has to include the $50. That's like her sunk cost. So the X and the Y is actually going to be pretty easy. We're going to, hold on a second. X is greater than 0 and Y is greater than 0 is going to be a solid line with everything shading up, and a solid line with everything shading that way. A lot of the times I like to signify shading that way by just putting an arrow on my graph to know that I'm going to shade that way. But if I shade it now, it's going to look really messy. So that's X is greater than or equal to 0, and Y is greater than or equal to 0. So let's talk about our other ones. X plus Y is less than or equal to 70. It's easy to graph. We just need to use our our intercepts, our y-intercept and our x-intercept. To find our x-intercept, we do y is equal to 0 and solve for x. X equals 70. And then set x equal to 0 and solve for y. Y is 70. So we're graphing this and this. Let's see if we can go by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. Five, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. So this is it's a solid line. and it is less than 70. So we're shading that way. Okay, our last equation is 50 plus 2x plus 3y is less than or equal to 215. Okay, let's find out what our x-intercept and our y-intercept is. To find our x-intercept, we set y equal to 0. So we have 50 plus 2x plus 3 times 0 equals 215. Solve for x. Pause. 2x equals 165. X equals 82.5. We're off the graph. That's a bummer. Okay, find our y-intercept. 50 plus 2 times 0 plus 3y equals 215. 3y equals minus So now we're going to graph those intercepts, and unfortunately our x-intercept is off the graph. So it's going to be up a little bit higher, and I'm not going to be able to get it in there. You see a little dot forming up there, and our y-intercept is 50. Sorry, our x-intercept's over here on the x-axis. Awesome. It's going to be over here. Let me erase that y if I can. There we go. And so x-intercept is 82.5, y-intercept is 55, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. You can have a solid line going that way, and we are also shading below. So I'm actually going to use a different color for this one. So we're shading above this way, above this way, but below here and below here. So where everything matches, this is why it's so important to keep everything neat. I don't know if you consider this neat or not, but our shaded area, they're actually called constraints. It's where our solution is. So every ordered pair within this shaded area will give Lauren what she needs to make her plates. That means that X was our red plates and Y, I did it again, X was our red plates and Y was our gold plates. So that'll give us our ordered pairs in the solution region. Okay, let's try the next example. Leyla is selling hot dogs and spicy sausages at the fair. She has only 40 buns, so she can sell no more than a total of 40 hot dogs and spicy sausages. So we'll say X equals hot dogs, Y equals spicy sausages. Each hot dog sells for $2, and spicy sausage sells for $2.50. Leyla needs at least $90 in sales to meet her goal. Write and graph a system of inequalities that models the situation. So our first equation is count of hot dogs and spicy sausage. Our second equation has to do with money. Okay, she can't have any more than 40. 40 is the most, so it has to be less than. How much she has is less than. And she wants to make more than $90. Oh, I forgot a Y in there. Sorry about that. There you go. So write and graph. We're going to solve, So I'm also going to write down X is hot dogs. And Y is, what are we calling them? Spicy sausages. So we also have two more parts to the inequality. We can't have negative hot dogs, so X has to be greater than or equal to 0. And Y has to be greater than or equal to 0. So we're going to graph these inequalities and to model the situation. That means for this equation and this equation, we're going to do our x-intercept and our y-intercept. And these are just going to make everything positive. So y was our spicy sausages, right? That has to be positive. X is our hot dogs, and that has to be positive. Okay, the other equations that we had, so that was x is greater than or equal to 0, y is greater than or equal to 0, x plus y has to be less than or equal to 40 because she only has 40 hot dog buns. That means our x-intercept is 40 because we set y equal to 0 and solve, and our y-intercept is 40 because we set x equal to 0 and solve. 5, 10, 15, 20, 25, 30, 35, 40. 5, 10, 15, 20, 25, 30, 35, 40. Draw a line, and it's less than, so this line is shading down. Okay, the other one is 2x plus 2.5y is greater than or equal to 90. Our x-intercept, y would be equal to 0, so x equals 45. Our y-intercept, x equals 0, y equals 36. So let's graph that next equation. X is 5, 10, 15, 20, 25, 30, 35, 40, 45. And y is 36. 5, 10, 15, 20, 25, 30, 35, 36. Get your straight edge out. Graph your line. And this one is pretty tricky. So that second line I drew is greater than, which is this way. So if you carefully shade, where everything overlaps is just in this itty bitty little piece of pie. And when you do that on paper with straight edges, it'll be so much more accurate than this just is. So this one shades this way. This line shades down, the first line with the x-intercept and the y-intercept of 40. And the last line shades up, that had the x-intercept of 45 and the y-intercept of 36. So the overlapping region is the solution region. That is how many spicy sausages and hot dogs that she is able to sell. Okay, you try this one. You guys can do it. So there are our system of inequalities, and the next page I'm going to work on graphing them. And there you go. I graphed x is greater than 0, y is greater than 0. I took my first equation, found the x-intercept and the y-intercept. I took my second equation, found the x-intercept and the y-intercept. And this shaded area is the amount of water bottles they can sell to meet their goal.